Hello and good morning to everyone. This is Devasis Mohanty once again welcoming you all to our real number discussion. So today the topic of the discussion is revisiting our rational number and its decimal expansion. Actually, why it is revisiting? Actually, we have already visited about the rational number and its decimal expansion in our standard 9. So it is for the second time we are going to visit our rational number and its decimal expansion related thing. Okay, so before we have to get any of the conclusion, I want to show you something. So first we will get the we will do the discussion of the decimal expansion of different types of rational number. So first I have already collected a few of the rational number, and also I have collected and also I separated them it into different groups of rational number, different group of rational number. Thereafter from each of the group one conclusion we will get. Okay, and whatever the rational number I have collected, all the rational numbers are in the co-prime form. Both the numerator and the denominator both are the co-prime numbers. Okay, so first I am showing you one number, it is 1 by 2. Another one it is our 1 by 4, another one it is our 1 by 8, another one it is our 1 by 16, and another one it is our 1 by 32. So whatever the rational numbers I have collected so far, all the rational numbers, in all the rational number, the numerator and the denominator both are the co-prime numbers. Okay, so first I want to find the decimal form of the 1 by 2. So decimal form of 1 by 2, it is your 0.5. Decimal expansion of 1 by 4, it is also your 0.25. Decimal expansion of 1 by 8, it is your 0.125. Decimal expansion of your 1 by 16, it is your 0.0625. And decimal expansion of 1 by 32, it is your 0.03125. So everywhere we got that the decimal expansion of these rational number, it is terminating decimal expansion. So it means all the collection, whatever the collection we have already done, 1 by 2, 1 by 4, 1 by 8, 1 by 16 and 1 by 32, all of its decimal expansion, it is terminating. So then after I just want to check the prime factorization of the denominator. So denominator at anywhere it is 2, then after 4, then after 8, then after 16, then after 32. Everywhere I got that the denominator in the first case it is 2 to the power 1, in the 4 denominator it is 2 square, in the 8 it is 2 cube, 16 it is 2 cube, 2 to the power 4, and 32 it is our 2 to the power 5. So it means everywhere I got that the power all the denominator having the prime factorization, it is in the form of 2 to the power m. 2 to the power m. Okay, so also one can say that it is in the form of 2 to the power m into 5 to the power 0. Actually 5 to the power 0 means 1, for which I can write 2 to the power m into 5 to the power 0. Also commonly one can say it as the prime factorization of all the denominators of these rational number, it is in the form of 2 to the power m into 5 to the power n, where m and n are the non-negative integers. So 5 to the power 0, 0 means also non-negative, it is 0. Okay, so then after it is one thing, it is clear. So the rational number whose whose decimal expansion it is, terminating. So it means whenever we will check the denominator of these rational number, always we will get their denominator are arranged in the form of 2 to the power m and 5 to the power n. So another group of collection we will do the discussion and in that group the rational numbers are 1 by 5, 1 by 25, 1 by 125, 1 by 625 and 1 by 3125. In the first case 1 by 5, its decimal expansion it is 0.2, and 1 by 25 its decimal expansion it is 0.14, 1 by 125 its decimal expansion it is 0.008, and 1 by 625 its decimal expansion it will be 0.0016, and the decimal expansion of 1 by 3125 it is our 0.00032. Here also the decimal expansion of these collected rational number also terminating decimal expansion. So whenever we will do the checking of the denominator of these rational number, always we got it as the factorization of the denominator, it is either 5 to the power 1, otherwise 5 square, otherwise 5 cube, otherwise 5 to the power 4, otherwise 5 to the power 5. Okay, so commonly one can say it as the denominators are written in the form of 5 to the power n. Also in additional, one can say it as, we can write the 5 to the power n, it is in the form of 2 to the power 0 into 5 to the power n. And then after also one can say it as the factorization of the denominator of all these rational number. We can write it in the form of 2 to the power m and 5 to the power n, where m and n are the non-negative integers. So one can say that the rational number whose denominators we can write it in the form of 2 to the power m and 5 into 5 to the power n, their decimal expansion, it will be terminating always. In the two groups we got the data this much. Then after another group we are doing the checking. So in the another group, so first rational number I have collected 1 by 10, then after 1 by 20, 1 by 40, 1 by 50, 1 by 100 and 1 by 1000. And we have already got the decimal expansion of 1 by 10, it is our 0.1, decimal expansion of 1 by 20, it is our 0.05, the decimal expansion of 1 by 40, it is our 0.025, and the decimal expansion of 1 by 50, it is your 0.02, decimal expansion of 1 by 100, it is your 0.01, the decimal expansion of 1 by 1000, it is your 0.001. Everywhere we have checked the decimal expansion of these collected rational number, it is always terminating decimal expansion. So for which whenever we check the denominator of the rational number, always we got that the factorization of the denominator, it can be written in the form of 2 to the power 1, 5 to the power 1, somewhere 2 square 5 to the power 1, somewhere 2 cube 5 to the power 1, somewhere 2 to the power 1 5 square, somewhere 2 square 5 square, somewhere it is 2 cube into 5 cube. So it means in this group of the rational number, always we got that the rational number its denominator can be written as the factorization of 2 to the power m into 5 to the power n. So it means we can say after checking this group that the rational number whose denominator can be expressed in the form of 2 to the power m into 5 to the power n, its decimal expansion, it will be 100%, it will be terminating. Is it okay or not? Then after another group we are checking. In the another group, one of the rational number, it is 1 by 6, another one it is our 1 by 12, next one it is 1 by 3, next one it is our 1 by 7, next one it is our 1 by 9. And the first rational number 1 by 6, its decimal expansion, it will be 0.16666666. It means non-terminating recurring. 1 by 12, it is our 0.0833333, non-terminating recurring. The next one, it is 1 by 3, it is your 0.333333, and 1 by 7, it is your 0.142857, 142857, 142857, and 1 by 9, it is your 0.111111. So it means from these collected rational number, we got their decimal expansion, it will be non-terminating and recurring. But then after I want to check the decimal, the factorization of the denominator of these collected rational number, and I got that the first rational number, its denominators and its factorization is 2 to the power 1 into 3 to the power 1. Another one it is 2 square 3 to the power 1. Another one it is 3 to the power 1. Another one it is 7 to the power 1. Another one it is 3 square. It means from all these rational number, one thing it is clear, their denominators are not written in the form of 2 to the power m into 5 to the power n. So it means one thing it is clear, whenever the decimal in the rational number, the factorization, otherwise the denominator cannot be written in the form of 2 to the power m into 5 to the power n, their decimal expansion, it will not be terminating, it will be non-terminating and recurring. So from all these 4 different types of group discussion, 3 things we got, and these 3 discussions, these 3 conclusions are also the 3 theorem, and now you just have to only remember the conclusion of the 4 group discussion. First one, it is if x is a rational number and x is in the form of a p by q, and where q it is the denominator, and if the decimal expansion of the rational number x, it is our terminating, then q can be expressed, it is in the form of 2 to the power m into 5 to the power n. Ready? Another one I am saying that if x is a rational number and x is in the form of p by q, where p and q are co-prime numbers, and if the q can be expressed in the form of 2 to the power m into 5 to the power n, then after the rational number gives us a terminating decimal expansion. Another one is third one, you just have to remember, if x is a rational number where the x it is in the form of a p by q, and where q cannot be expressed in the form of 2 to the power m into 5 to the power n, then after you just have to remember the rational number x gives us the non-terminating and recurring decimal. Actually, rational number means its decimal expansion, it will be either be terminating, otherwise non-terminating, recurring. So from now onwards you can say it easily which rational number decimal expansion it will be terminating and whose decimal expansion it will be non-terminating and recurring. Just remember by checking the denominator, but before the checking the denominator you just have to make it in the co-prime form. Then after you just have to check the denominator. If the denominator it is in the form of 2 to the power m into 5 to the power n, then after it will give you the terminating decimal. If it cannot be written in the form of 2 to the power m into 5 to the power n, 100% it will not give you an non-terminating decimal expansion. Instead it will give you the non-terminating and recurring decimal expansion. Is it clear to everyone? So now we will apply all these things to solve the exercise 1.4 question number 1, 2, 3, 4. Just wait. So now in the question number 1 of exercise 1.4, it is given that without doing the division you just have to say whether the rational number it is our terminating, otherwise non-terminating, recurring. Actually rational number means 100% it will be terminating, otherwise non-terminating, recurring. So for which first one it is one of the rational number it is given which is equal to 13 by 3125. So I said you few of the trick you just have to remember. First you just have to check whether the numerator and the denominator both are co-prime or not. So first you have to check the co-prime or not, and after checking the co-prime and after making both the numerator denominator it has the co-prime number, then after you just have to check the denominator. If the denominator it can be factorized in the form of 2 to the power m into 5 to the power n, then after we can say that this one it is your terminating, otherwise it will be non-terminating, recurring. Okay, so first question it is 13 divided by 3125, and 3125 can be factorized it as the 5 to the power 5. And the numerator denominator nothing can be cancelled. Okay, so it means both are the co-prime numbers. So it means 5 to the power 5. So 5 to the power 5 means 2 to the power 0 into 5 to the power 5. Otherwise one can say it normally that 5 to the power 5 which is also in the form of 2 to the power m into 5 to the power n. So for which 13 divided by 3125 it will give us a terminating decimal. It will give us a terminating decimal. Understood or not understood? Then after next question it is 17 divided by 8, and here it is 8 can be factorized it as the 2q, and 17 and 8 both are the co-prime number, and here it is 8 can be factorized it as the 2 to the power 3. 2 to the power 3 means 2 to the power 3 into 5 to the power 0. Otherwise one can say that the denominator can be expressed in the form of 2 to the power m into 5 to the power n. So the rational number whose denominator can be expressed in the form of 2 to the power m into 5 to the power n, it will give us the terminating decimal always. Okay, next question 65 divided by 455. Here it is 455 can be factorized it as the 5 into 7 into 13, and 64 and 455 are co-prime number, because on factorizing the 455 we are getting it as the 5, 7 and 13, and the 64 cannot be factorized with any of the factor of 5 and 7 and 13. So for which numerator and denominator both are the co-prime numbers, and here it is clearly seen that the denominator cannot be written in the form of 2 to the power m into 5 to the power n. So for which the rational number gives us non-terminating and recurring decimal expansion. Next one it is our 15 divided by 1600. Here 15 can be factorized it as the 3 into 5 upper one, and the denominator can be factorized as 2 to the power 6 into 5 square. Upper one having the factor 5, and also below one it is also having the factor 5. So 1 5 can be cancelled. So it means after simplifying it becomes 3 divided by 2 to the power 6 into 5. So now the rational number it is in the simplest form, and both numerator and denominator are in the co-prime form. Here it is the denominator factorization form, it is 2 to the power 6 into 5. So it means already it is seen that the 2 to the power 6 into 5 to the power 1 it is already in the form of 2 to the power m into 5 to the power n. So for which 15 divided by 1600 it will give us the decimal expansion which will be terminating decimal expansion. Okay. Next question, it is 29 divided by 343. In the 29 divided by 343 means denominator can be factorized it as the 7 cube, and numerator and denominator both have the co-prime number, so for which the denominator it is clearly seen that the power of 7, but it cannot be written in the form of the 2 to the power m into 5 to the power n. So for which, as the denominator cannot be expressed in the form of 2 to the power m into 5 to the power n, so for which the rational number will give the decimal expansion which is non-terminating and recurring. Next one, it is 23 divided by 2 cube into 5 square. So both have the co-prime. 23 cannot cancel any of the factor of the denominator, for which denominator it is clearly seen that the power of 2 to 2 and power of 5, otherwise in the form of 2 to the power m into 5 to the power n. So for which the decimal expansion it will be terminating. Next question, it is 129 divided by 2 square into 5 to the power 7 into 7 to the power 5. So nothing can be cancelled with both the numerator and denominator. It means numerator, denominator both are in the co-prime form. First you just have to check the co-prime or not. Okay, if anything can be cancelled, first you have to cancel, otherwise our formula cannot be applicable at here. Okay. So nothing can be cancelled, and here it is the denominator, it is not in the form of 2 to the power m into 5 to the power n only, extra 7 to the power something is coming, but our formula it is only it can be expressed in the form of 2 to the power m into 5 to the power n. Don't say that sir 2 to the power m, 5 to the power n is there, extra also 7 to the power anything is there. So my formula it is only 2 to the power m into 5 to the power n, no any of the other factors should be there. Okay, so for which it will be our non-terminating and recurring decimal expansion. Next one, it is 6 by 15, which is not in the co-prime form, so for which once again simplifying and it becomes the 2 by 5, and after making it as the 2 by 5, the denominator I have checked, the denominator it is 5, which is equal to 5 to the power 1, and it can be expressed in the form of 2 to the power 0 into 5 to the power 1, which we can say that it is in the form of 2 to the power m into 5 to the power n. So for which 6 by 15 it is our terminating decimal, it will give us the terminating decimal. Next one, it is our 35 divided by 50. Here both are not the co-prime number. After simplification we got it as the 7 by 10. After simplification we got it as the 7 by 10, and the denominator 10 can be factorized it as the 2 into 5, which can be written in the form of 2 to the power 1 and 5 to the power 1. Otherwise one can say that the denominator can be expressed in the form of 2 to the power m into 5 to the power n. So for which the rational number gives us the terminating decimal. Then the last question of the question number 1 bit is 77 divided by 210, and here both are not the co-prime numbers, so for which once again we are doing the simplification. After simplifying it becomes 11 divided by 30, and 30 can be factorized it as the 2 into 3 into 5, but we want only the factor of 2 and factor of 5, but here we are getting that the 2 5 along with also we are getting the 3, so for which we cannot say that the denominator cannot be expressed in the form of 2 to the power m into 5 to the power n only, so for which this rational number gives us the non-terminating and recurring decimal. Actually the decimal expansion of the rational number, either it will be terminating, otherwise non-terminating recurring. If it fails to satisfy the terminating, it means 100% non-terminating recurring. Okay, so before we have to do the question number 2, now I want to show you the question number 3. In the question number 3 it is given that the decimal expansion it is given. The decimal expansion it is given. By seeing the decimal expansion you just have to say, by seeing the decimal expansion you just have to say the rational number. If it is the decimal expansion of the rational number, you just have to say what is the property of the denominator. What is the property of the denominator? If the rational number, see in the first bit question number 3i 43.123456789, so it means 100% it will be our terminating decimal. As it is the terminating decimal 100%, it will be the terminating of the rational number form. So 100% the rational number, its decimal expansion it will be terminating. So 100% whatever the rational number it has, whose decimal expansion is this number, 100% that denominator can be expressed in the form of 2 to the power m into 5 to the power n. Otherwise that rational number, the denominator can be factorized it as the power of 2 and factorized power of 5 only. Power of 2 and power of 5, otherwise 2 and 5 are the only factors of the rational number whose decimal expansion is this one. Next one it is 0.120, 1200, 12000, and 1240. Actually this one it is not the non-terminating, and this one it is the non-terminating and non-recurring, for which this one it is not a rational number, it is the irrational. It is the irrational number. Okay, so for which I cannot say the property of the denominator. Then after 43.123456789 recurring, as it is non-terminating and recurring, so 100% this one its rational form we can find out, because this one it is the rational number. Rational number its decimal expansion, it will be non-terminating and recurring. But one thing it is clear, that the denominator cannot be expressed in the form of 2 to the power m into 5 to the power n. Okay, other than 2 to the power m into 5 to the power n, here the denominators we will get something different. Okay, now you just have to wait for the question number 3. Question number 3. In the question number 1, it was given that without any division, you just have to say that the rational number whose decimal expansion it will be terminating and whose decimal expansion it will be non-terminating and recurring. But the question number 2, it is given, you have to just find out the decimal form. You just have to find out the decimal form of that rational number whose decimal expansion it is terminating. Whose decimal expansion it will be terminating, you just have to find out the decimal form of that rational number. Okay, so first number it is 13 divided by 3125. So which is equal to 13 divided by 5 to the power 5. Remember one of the formula you just have to remember, whenever you are checking the denominator factorization of the denominator, there is 5 is there, 2 is also there. As this one it is our terminating decimal, 100% this one it is giving you the terminating decimal expansion. It means the rational the denominator factorization 100% having the 2 and 5. Your task is only you just have to check whenever you need to find out the decimal expansion. Your formula is only you have to check the denominator factorization 5 and 2. How many 5 and how many 2? Which one it is greater? Suppose here it is 5 is 3 and here it is 2 it is there. 5 is 3, so for which you just have to multiply 2 here and also 2 in the numerator. Understood or not understood? Suppose here it is 5, number of 5 it is 5 in number, and number of 2 it is 2 in number. Okay, so to convert it into decimal expansion, so here it is 3 lacuna, so for which 3 2 you have to multiply in the denominator, also 3 2 you just have to multiply in the numerator and the denominator both. Understood or not understood? So here it is given that 13 divided by 5 to the power 5. So in the denominator no 2 is there. So how many 5 is there? 5 is there. So no 2 is there. It means 2 we will multiply 5 in a number. It means 5 number of 2 you have to multiply. So that number of 5 and number of 2 it will be balanced. Why we are balancing? Just I will say to you. So upper one it is 2 to the power 5. Below one it is 2 to the power 5. So upper one, whenever we will multiply 13 into 2 to the power 5, it becomes 416. And below one it is, remember, 1512 means 10. 2522, it means 0, 0, it means 100. 3532 means 1 followed by 30 means 1000. 4542 means 10,000. 555 and 52, it means a lakh. Understood or not understood? So it is the easier one, you just have to get the decimal expansion. Okay, so here it is 55 and 25, it means the product it will be 1 followed by 50. So for which 416 divided by 1 lakh, its decimal expansion it will be 0.00416. Ready? And the next question it is 17 divided by 8, which is equal to 17 divided by 2q. See the denominator. In the denominator, the highest power of a 2 it is 3. 2 it is 3, no 5 is there. So it means 5 we will multiply in 3 in numbers. Okay, so here it is 2, it is in 3 numbers. 2 it is in the 3 numbers, but no 5. So for which also we will multiply 5 in 3 number. In the denominator also we will multiply 5 in 3 numbers. Also in the numerator also we will multiply 5 in 3 numbers. So the numerator becomes 17 into 125. And here it is 2, 3 number of a 2 and 3 number of a 5. So 1 2 1 5 1 0 means 10. 2 5 2 2 2 5 means 1 followed by 2 0 means 100. So 3 2 3 5 means 1 followed by 3 0. It means 1000. So numerator product it is 2125 divided by 1000. Whose decimal, from the decimal fraction we can convert the decimal number 2.125. Okay. How easy? I think this one it is very easy, I feel. Okay, next one it is 15 divided by 1600, which is equal to, after simplification we got it as the 3 divided by 2 to the power 6 into 5. Okay, and in the denominator number of a 2 is 6 in number. Number of a 2 is 6 in number, but number of a 5 is single 5. Okay, so which one it is greater? Number of a 2 it is greater 6, and here it is 1. 5 is 1, so we just have to make it balance. Greater one it is 6 and smaller it is 1. So which one it is smaller in number? In that smaller we have to multiply the same number of lacuna 2. Okay, so 2 it is 6 in number, 5 is 1. So for which 5 we have to multiply in the denominator, also in the numerator. It means 5 to the power 5 we will multiply the denominator, such that in the denominator number of a 5 it is 6 in a number, and a number of a 2 it is also 6 in a number. Okay, and the denominator numerator becomes 3 into 3125, and the denominator becomes 10 lakh. So the numerator product it will be 9375, and the denominator becomes 10 lakhs. So its decimal expansion it will be 0.009375. And next question it is 23 divided by 2q into 5 square. Here it is number of a 2 it is 3 in a number, number of a 5 it is 2 in number. So it is the greater one it is 2. So 2 it is in the 3 numbers, and here it is 2 number. So another 5 I have to multiply in the numerator, also another 5 also it is to be multiplied in the denominator. So here the numerator product 23 into 5 is equal to 115, and the total number of 2 it is 3 in number, and total number of 5 is 3 in number. So 1 to 1 5 means 10, 2 to 2 5, 100, 3 to 3 5 means 1000. So for which the decimal fraction it is 115 divided by 1000, and the decimal number it is our 0.1115. Then after 6 by 15, after simplification we got it as the 2 by 5. Here it is a single 5 it is there, no 2 in the denominator, for which single 2 I have to multiply in the denominator, also single 2 I have to multiply in the numerator, which is equal to 2 by 5 into 2 numerator into 2 denominator, which is equal to 4 by 10. It is easy, that 0.4 it is. Okay, next question it is 35 by 50. 35 by 50, after simplification we got it as the 7 by 10. 7 by 10 it is already in the decimal fraction, so for which no need to take worry, directly we can convert it as the 0.7. So I feel that the exercise 1.4 all questions are very easy for you, I feel. Okay, but it may be easy, otherwise it is, suppose many of the students if you are feeling it is little bit difficult one, so you have to keep practicing, and all these tasks I want you to do in the CW copy. Okay, and your total chapter 1 it is already completed. Very soon I am going to conduct one of the online test, so only the objective type question I am going to ask you. Understood or not understood? So you have to keep completed everything and keep practicing in your rough copy. Thank you. Have a beautiful day.